All right, today we are going to be doing adding and subtracting radicals. It's a little change of pace from what we've been doing the first three lessons, which was all multiplication and division. So I'm going to do some stuff that we've done in the last couple units to show you what's happening with radicals, to show you that it kind of follows the same pattern. So the first two questions up there are from unit 6. 2x to the third times 4x to the third was 8x to the sixth. X to the fifth times 3x squared was 3x to the seventh. The next two are from unit 7, which is polynomials. 2x to the third plus 4x to the third was 6x to the third. And x to the fifth plus 3x squared, I couldn't put those together. It just stayed x to the fifth plus 3x squared. Okay. What did I just show you there? Why did I show you that? When multiplying, which was numbers 1 and 2, we can multiply unlike terms. Unlike terms is like number 2. We could multiply those together. They had different exponents. That's what made them unlike terms. And the exponents will change in your answer. Right? So they were 5 and 2 and it changed to 7. Number 1, we multiplied 3 and 3 and it became 6. Right? When adding or subtracting, which is like numbers 3 and 4, we can't add or subtract unlike terms. That's number 4 here. And the exponents will not change in your answer when you can put them together. So in number 3, I was able to put those together, but the exponent didn't change. All we did was we added the coefficients. Okay, why did I show you all that? That was unit 6 and unit 7. How does this apply to radicals? Well, let's see. The 3 radical 6 plus 2 radical 5. We've done that before. That was lesson 1. That was 6 radical 30. Multiply the outside stuff and the outside stuff with the inside stuff and the inside stuff. 3 radical 6 plus 2 radical 5. Now it's plus. We haven't done this yet, but I'm going to tell you that that is 5. That is 3 radical 6 plus 2 radical 5. I can't do anything with that. Number 3, again, we haven't done this yet, but I'm showing you that 7 radical 3 plus 4 radical 3 is 11 radical 3. So how does this apply? When multiplying radicals, we can multiply unlike terms, so different radicals. Right? So number 1, they had different radicals, numbers under the radical, so we were still able to multiply them. And the number under the radical will change in your answer. Okay. When adding or subtracting, we can't add or subtract unlike terms. That's number 2. I couldn't do anything with those. Okay. They're unlike terms because they have different radicals. If they have the same radical, like in number 3, the number under the radical will not change in your answer. Notice it was radical 3, and the answer was also radical 3. All we did was we added or subtracted the coefficient or the number in front of the radical. Just like with polynomials, it's the exact same scenario. Okay, so let's do a couple basic practice problems here. Find the difference or sum or difference. So I can only put together the like terms. So radical 7 and radical 7. So 4 radical 7 plus 5 radical 7 is 9 radical 7 plus 7 radical 2. And that's as far as I can go. And that one's done. Okay, next one. They're both radical 6. There's a 1 right here. 5 radical 6 minus 1 radical 6 would be 4 radical 6. Now you're probably thinking, oh, this is awesome. This is super easy. You're right, it is. But there's a catch, of course. Always is, right? Here we go. Here's the catch. Simplify 3 radical 5 plus radical 80. You might be looking at that and say, you can't. They're unlike radicals. You would be correct. They are unlike radicals. So we can't combine them, right? Wrong. However, square root of 80 can be simplified further, which we must do before we say we are done. So if you're thinking you're done, you got to make sure all the numbers under the radical are as simplified as they can be. So square root of 80, here we go. I'm gonna do this quickly because you've been doing this for a long time. 8 and 10, 4 and 2, I'm going off to the side here. 2 and 2, 10 is 5 and 2. So that's a pair of 2s, another pair of 2s, so that's 4 radical 5. When simplified, square root of 80 becomes 4 radical 5. And now we have like radicals. They both have square root of 5. So now what I have is 3 radical 5 plus 4 radical 5. Now I can put them together, and the answer is 7 radical 5. Okay, so we're going to try it. Couple, 3 problems here, and then they get a little harder, of course. Oops. All right, there we go. Square root of 27 minus the square root of 12. Can't do anything with that yet. A lot of people are going to say, oh, square root of 15. Don't do that. Don't fall for that trap. I'm going to simplify both the square root of 27 and the square root of 12. We've done this a lot, so I'm not going to spend a ton of time showing you how to simplify this. Square root of 27 is 3 radical 3. Square root of 12 is 2 radical 3. Now they're like radicals. Now I can combine them. 3 radical 3 minus 2 radical 3 is 1 radical 3, or just radical 3. Number 2. You should hopefully see that those are both perfect squares. The square root of 25 is 5. The square root of 64 is 8. These are like radicals. I mean, you wouldn't normally classify them that way, but they have nothing under the radical. So 5 plus 8, 13. Number 3. 18. Again, not going to spend a ton of time on simplifying this. I'm actually going to spend no time on it. That's 3 radical 2. Square root of 36 is actually a perfect square. It's just 6. These are unlike radicals. I cannot put them together. A lot of people are going to put 6 and 3 together and say 9 radical 2. I can't do that. 6 does not have a radical, so it's not a like radical. So this one is 3 radical 2 plus 6. That's your answer. All right. 4 little bit tougher ones. The reason they're a little bit tougher, I think, is because of the numbers on the outside. I can't put those 6 and 2 together and make 8, but what I have to remember to do is multiply whatever comes out of 27 and whatever comes out of 75 by that number. So 27 is 3 radical 3. And now I got to remember to multiply 6 and 3. 75, square root of 75 is 5 radical 3. And now I got to remember to multiply 2 and 5. So 6 and 3 is 18 radical 3. 2 and 5 is 10 radical 3. Now I can multiply or add those together. 18 and 10 is 28 radical 3. Number 5. So 200 is, let's see, 10 radical 2. 50 is 5 radical 2. Multiply the 3 and the 10, multiply the 6 and the 5, I get 30 radical 2 minus 30 radical 2. Well, 30 radical 2 minus 30 radical 2, everything's gone. You just have 0. And that can't happen. You could put 0 radical 2, but 0 times anything is still 0. All right, number 6. Don't forget the 2. Very common mistake I see. There's no number outside of 108 that I need to worry about, so I'm just going to put the parentheses there. 54 is 3 radical 6. 108 is 6 radical 3. I'm going to multiply 2 and 3 and say 6 radical 6 plus 6 radical 3. Don't fall for the trick here. You can't put those together. That's your answer. So it's 6 radical 6 plus 6 radical 3. Last one. Square root of 40 minus 2 times the square root of 90. Square root of 40 is 2 radical 10. Square root of 90 is 3 radical 10. So 2 radical 10 minus 6 radical 10 is negative 4 radical 10. Okay. Notice how on all 4 of these problems, I had a little bit of work, 1, 2 steps before I got to the final answer. I still see every year I see people who think that they can do it in less steps than I can. Don't try. Please do take the time to show the work. You're going to thank me later if you do. That's adding and subtracting. Next is kind of a combo of multiplication, adding, and subtracting.